Good evening, everyone. I will be explaining our project title, Detect and Count Hazardous Substance in Metal Scrap, which we create out for one of our leading alloy manufacturer. So let's come to the business problem. Our main business problem here is that alloy manufacturers often use large quantity of metal scrap as a raw material in their furnace. But sometimes what happens, this scrap contain hazardous or closed vessel. For example, gas cylinder or sealed containers. Where these are exposed to high temperature inside the furnace, they got exploded, posing a serious safety risk which leads to damage of the workers and all. Now comes to the business objective. Our main business objective is to make furnace operation safety, minimize the maintenance issue. We also want to keep the cost low and ensure real-time detection of hazards material before the scrap entered into the furnace. So we have to focus on extracting the hazardous substance which might get blasted before keeping it into the furnace. Now comes to our success criteria. We divide this into three major parts. Comes to business success criteria, ML success criteria, or economic success criteria. When it comes to business success criteria, we aim to reduce the furnace explosion incident by 90%, ensure a much safer work environment. Now comes to ML success criteria. Our goal is to achieve at least 85% detection accuracy. Mean the model should be reliable to identify closed vessel and hazardous item automatically. Now comes to economic success criteria. We target to bring down the maintenance and repair cost by 85%, which would make significant financial impact for the company. So in short, here in this project, we are helping in detecting hazardous substance in real time so that we will not get any harm, make the manufacturing process safer and smarter. And it should be more efficient and it should be more cost efficient. So this is all about this project. Let's focus on what kind of data set we gather. So from the name of the project itself, we can understand that this is related to computer vision project, where we need to focus on image data, image processing data. So if you see this image processing, here in the script, in the script part, we have explosive part. These are all cylinder present in our script, which might get exploded if it comes in contact with high temperature. So we need to focus on all this. We need to detect all this material so that before putting it into the blast furnace, we will take care of it and we will extract all this. So this is the data set which we are dealing with. We are focusing on image data because this is a computer vision project. Now let's come to our architecture diagram, which showcases the flow which we are dealing with to complete this task. So here in this architecture diagram, we start with our business objective. We will first understand the business problem, what is this business problem all about, and then we proceed with the flow of the project. So we identify the main goal is to count the hazardous substance or item like gas cylinder or aerosol can or fire extinguisher present over here. The purpose is to improve the work safety and reduce the maintenance cost by avoiding the furnace explosion. Now we move towards data understanding. So we need to understand the data thoroughly. In this stage, we collect all our image data, basically the image of the different hazardous material. Here we focus on the 7 different hazardous material, which might be cylinder, tank, battery. So we then queue and segment those data in their types. We also ensure class balance, because class balancing is very important. We focus more on this class balancing, that whatever the different segment that we focus on, we need to balance it down, so that model will not get biased towards any particular segment or any particular category. Once we have collected data, queue it up, then segment it down according to different categories, and then balance it accordingly by performing like uh, image augmentation and all. Then we proceed with the goal of annotation. Here we come up with data pre-processing, where we prepare the data for training. We start by annotating the image, that obviously that we are doing it in RoboFlow. This means manually marking the exact region of each image where the hazardous object is located, like drawing bounding box around the explosive object. Then for that, first we proceed with digital screening. Then after we work on RoboFlow. Before performing this annotation, we first stick to data augmentation, which help us in creating balancing in the data. We have different segment of the hazardous substance. We focus on performing augmentation, so that we can flip it, rotate it, adjust the brightness accordingly to the image, make it resizing, normalizing, and all. We perform all these tasks so that we end up with having a data set which is balanced, which have sufficient sort of image present over there. After that, we move to the model building phase. Once we move to the model building, here we have used different YOLO series of model. Apart from this, we also have used several other model apart from YOLO. Then we go and find the MAVE value for each and every model. We feed the data, we find the MAVE value. This is the formula to find the MAVE value. Or like we proceed with the evaluation of the model. We find the MAVE value for each and every model and save it down. Once we save it down, then we go and find which model is performing best. After finding the MAP value, we will go and find whichever model is performing well, whether the model is performing gone with underfitting, overfitting, or balancing or not. We go on through all this constraint, keeping in mind all this constraint, we go and select the best model. So according to our use case, we came up with YOLO 8. YOLO 8 performed the best out of all the model that we have selected. Once we once we go check the performance of the model, get the feedback by going in several loops, we end up with creating a UI by using Flash, where we feed any data set and it will perform all the operation into it, and then it will also showcase the MAP value, MCP value for each and every model. And it also showcase, it can also showcase which detect the explosive material in the uploaded data. Apart from detecting, here it not only detect the explosive material, but apart from this, it also help us in detecting and counting of the explosive material according to the segment that we have performed here. So we have already discussed that here we make it in different segments like cylinder, tank, battery, and all. Once we have gathered it, then we come to the conclusion of our project, and once we get any new data set, then any new data set in the sense that once it will get any image where we are having different explosive part, that it not only detect it, but it will also count it. So this is all about the project that we are having. Now comes to what we have offer. We offer real-time project. We will also push our limit to complete those project, real-time project for our client. We also focus on having different methodology, which we focus while creating project. Here in 360 DigiTMG, we focus on creating project related to CRISP MLQ methodology. Then we also focus on different tools like Python, Power BI, Cloud Platform. Then we also have our research paper being published. We uh, allow our student to publish their research paper, and we also have various access to mind map, ML architecture, resume optimizer, and animated learning. So this is what we focus. If you want to contact us, then you can go and call us in this number. And if you want to be connected with us by our YouTube channel, so we also have our YouTube channel. Can go with. If you search for 360 DigiTMG. So here you can connect with us. You can go and see different course material that we offer free of cost. And if you want to see the success of our student and all, can go and visit it. So thank you all.